Thank you for joining us today. My name is Zhu Linqi. It is my great honor to moderate the GNF China Space Station Benefits Global Space Exploration. This forum is organized by China Manned Space Agency and Chinese Society of Astronautics. First of all, may I briefly introduce to you our distinguished guests. Professor Yang Hong, Chief Designer of China Space Station, China Academy of Space Technology, CAST. Professor Zhang Qiao, Director Designer of China Space Station, CAST. Professor Lü Congmin, Deputy Chief Designer of Space Utilization System of Manned Space Program, Chinese Academy of Science. Professor Nicolas Paudry, Professor at University of Geneva, Research Scientist. And Mr. Wu Lei, Producer and Senior Space Correspondent of China Global Television Network. Welcome to all of you. The Chinese ancient people dreamed about Tiangong, meaning sky palace, for thousands of years. In 2022, construction of China's Tiangong space station has been successfully completed. The dream comes true. China Manned Space Agency prepared a video entitled "A Dream Comes True: Tiangong's Exploration of the Boundless." Let's watch the video.
2022年10月31日，梦天实验舱成功发射，T 字构型的天宫空间站在轨组装完成。2023年6月4日，神舟15号乘组安全返回地面，空间站建造阶段任务圆满完成。 这是在以习近平同志为核心的党中央坚强领导下，新时代中国特色社会主义事业取得的重大成就，是人类探索浩瀚宇宙、和平利用太空的又一标志性成果。 日月安属，烈星安沉。中华民族逐梦9天的脚步从未停歇。中国载人航天工程自1992年立项实施以来，实现了从无人到有人，从舱内到舱外，从短期到长期。 从单船到组合体的一次次重大跨越，进入新时代，工程以新的蓬勃之势跨入加速发展快车道，特别是2020至2022年，密集实施12次飞行任务，高效建成具有世界先进水平的中国空间站。 载人航天工程3步走发展战略从构想成为现实，中国人有了属于自己的太空家园。空间站建造是我国迄今为止最具开创性、技术要求最高的重大航天工程。工程 将全线坚持自主创新，攻克了200余项核心关键技术，新技术新产品占比90%以上，核心器部件实现100%自主可控。空间站载荷装站重量比、天地数据传输速率、水回收再利用率等指标国际领先。大型空间设施在轨建造，近地空间长期载人飞行，大规模空间科学研究实验能力达到世界先进水平。信息技术、能源技术、出舱支持等技术独具中国特色，充分展现了中国智慧、中国方案、中国力量。建造空间站是建设科技强国、航天强国的重要引领性工程。火箭近地轨道运载能力跻身国际前列，航天器自主快速交会对接，创世界纪录。高精度大型控制力矩陀螺、大功率柔性太阳电池翼等一批新技术推广应用，规划开展空间生命科学与人体研究、微重力物理科学、空间天文与地球科学、空间新技术与应用等领域近1000项实验，将全面提升空间科学、空间技术、空间应用发展水平。征途漫漫，唯有奋斗。空间站建造充分发挥新型举国体制优势，系统谋划、创新管理，全国100多个科研院所、3000多个单位、数10万科技工作者团结一心，按照党中央擘画的宏伟蓝图，笃定前行，大力弘扬2弹1星精神和载人航天精神，以而今迈步从头越的自信与坚定，勇毅登攀，谱写了一曲曲社会主义大协作的时代凯歌。作为强国兴邦的战略工程，中国载人航天始终致力于服务民生、造福人类。4000余项技术成果广泛应用于国民经济各个行业，在生物材料、健康医学、农业安全、生态治理等领域发挥了重要作用。安排3000余项航天育种搭载实验，300个育成品种通过审定，航天育种水稻小麦大面积推广种植，显著提高了产量与品质。天宫课堂等科普活动，激发了广大青少年崇尚科学、追求梦想的热情，极大增强了全国人民建设创新型国家的信念信心，政治效益、经济效益、社会效益不断凸显。中国空间站不仅属于中国，也属于世界。本着和平利用、平等互利、共同发展的原则，与多个国家航天机构和国际组织开展合作，向世界开放中国空间站资源，启动实施17个国际合作项目。未来，国外航天员也将进入中国空间站，与中国航天员联合执行任务。随着工程进入空间站应用与发展和载人月球探测2大任务并行实施新阶段，必将为推动构建人类命运共同体做出更多中国贡献。 探索浩瀚宇宙，发展航天事业，建设航天强国，是我们不懈追求的航天梦。新时代，新征程，中国载人航天站在新的历史起点。中国人探索太空的脚步将迈得更稳、更远。
Thank you for watching. Now, please welcome Professor Yang Hong and Professor Zhang Qiao, who will speaking to us on frontier of space exploration, design, performance, and the future collaboration of China's space station. Professor Yang Hong is chief designer of China's space station of CAST, academician of Chinese Academy of Engineering, and academician of the International Academy of Astronautics, and a member of IAF Human Spaceflight Committee. Professor Zhang Qiao is director designer of China's space station of CAST. He participated in the system design and development of China's space laboratory and the space station. First, welcome Professor Yang.
Thank you, Ms. Zhu. Ladies and gentlemen, good morning. It's my pleasure to attend today's forum. First of all, please allow me to give a brief introduction to China Human Flight Program. In September 1992, China made a decision to implement the manned space program and prescribed the three-step development scheme. And the first step is to launch the manned spaceship, set up the primary integrated experiment manned spacecraft engineering, and carry out a space experiment. The completion of this step was marked by Shenzhou 5 spaceship mission in 2003. The second step, to make the technical breakthrough, such as EVA and space reservoirs and docking by manned spaceship and the space laboratory Tiangong 1. Provide solution for space application of the certain scale with the maintaining on a short-term basis. The completion this step was marked by Tiangong 2 space laboratory mission in 2017. The third step is to build space station and provide solution for space application of large scale with the maintaining on the long-term basis. China's space station consists of the three models, and the Tianhe core model, Wentian experiment model, and the Mengtian experiment model in a T-shaped configuration. The Tianhe core model is the control and the management the center of space station, and supplied the long-term residence of the astronauts. The main task of the Wentian experiment model is to serve as the backup the key platform function of the core model, and provide the airlock for EVA. The Mengtian experiment model has the ability for export payload go extravehicular automatically. On April 29, 2021, the Tianhe core model was successfully launched into orbit by Long March 5 5B rocket, as planned. By 11 launched and orbit mission, the construction of China space station has been completed in the end of 2022 and started operation of the space station. So I'm pleased to introduce my teammate, Dr. Zhang. He will show the design, performance, and the future cooperation of the China space station. Now, welcome Dr. Zhang. Thank you.
Thank you, Ms. Zhu. Ladies and gentlemen, thank you, Professor Yang. It's my honor to stand here for this speech about China's space station, about its design, performance, and the future collaborations. Okay. Today's introduction is shown in 4 parts. First of all, mission goals of China's space station. When we talk about the space station, we always review its history. The Mir, the world's first multi-module long-term space station within brush shape, assembling orbit and gradually extended. And the ISS, the largest spacecraft ever built by the human being, composed of 2 main regions, the module parts and the truss part. The mission of China's space station are as follows: operating reliably in orbit for a long time, providing guarantees for safety and astronauts to live healthily and work effectively, providing guarantees for the support of the multi-field scientific and technological experiment in space. The second part is system design of China's space station. For overall, the lifespan is more than 15 years and even more. 3 crew members in the normal case and up to 6 for the crew rotation case. It has a configuration of block building with a local truss. 3 modules in the same plane, large solar arrays of the experiment module arranged in both sides in 2 experiment modules, with 2 degree of freedom drive mechanisms for the highest power generation. The building process is through space rendezvous docking and the module transfer. As for the control and the propulsion system, computers, sensors, CMGs, thrusters in every module are connected with the databus and integrated resource utilization. CMGs are the main modes. Both forward and backward docking mechanisms of core module equipped with the propellant refueling interface with the system. Cargo spaceship at the backward can provide the cross-module propellant refueling system to Wentian space telescope. The car module equipped with 4 hot thrusters with 80 milliNewton, and the specific impulse is 1600 seconds, which slowing down the orbit decay rate. For energy, we use the standard 100 voltage system, large flexible solar arrays. The length of solar arrays in Mengtian and Wentian experiment modules equals 27 meters. In information system, multi-layer network architecture is shown. The bus handles the key data, and Ethernet handles high qualities of voice, images, and data of the payload. The relay coverage rate is approximate to 100%. As for the environment systems, both the core module and the Wentian experiment module equipped with regenerative high life support systems. Oxygen, waters are basically no longer depend on the ground support. So we have 2 robotic arms. Both of them are in 7 degrees of freedom. They can work in independent or combined modes and walk or crawl on the space stations. The arms are used for the module transfer, EVA assistance, equipment cooperations, exposed loading operations, capture visiting spacecraft, and even for the releasing small satellite. When the core module fly alone, the node is used as an airlock after Wentian experiment module coming, so we have the main airlock. And the equipment and exposed payload go outside through the cargo airship of the Mengtian experiment module automatically. Automatic docking mode is main for visiting spacecraft. Manual tele-operation docking modes by astronaut is backup. The weight of the 2 experiment modules are about 23 tons, and we use a 2-step unfolding scheme of the solar rays. It's huge, so we have the 2 steps. In our phase, quick rendezvous and docking chancing, they dock with the Tianhe car module in 13 hours. 2 experiment modules transfer from the forward hatch to the lateral berthing hatch in plane way by 2 joints plane transferring manipulator. In this process, passive stabilization scheme based on gravity gradient is proposed. That is a cartoon and the on-orbit missions of the transfer stage. For experiment support system, the pressurized payload is made by rack form, providing the mechanical, power, communication, thermal, and the vacuum resources. For exposed payload, by standard adapters or extended interfaces, providing the mechanical, power, communication, thermal, robotic arms resources. And the third part is technical performance and advanced nature. First, the top design of China's space station is independence, innovation leading, system guarantee, modular scale, and living space for development. And the design concept can be concluded as 1 = 1 + m. Not only means the space station is designed systematically in the very beginning, but also means all of the modules follow the uniform process, and the space station can manage all of the visiting spacecraft. And the 3-layer management architectures about station, module, and subsystem is formed in the design and the development process. Although the total equipment is more than 6,000, yet nearly 80% are universal. The design, verification, identification are conducted in the same time, making maturity improved. Then, high proportion of new technology and intelligence, including the brand new technologies, network technologies, gigabit network, Ethernet, smart home concept, autonomous health management, and so on. Also, the full 3-dimensional digital development and operation mode. Actually, China's space station is operated in 3 space station levels. We call it the real space station is in orbit, and we have an electric space station in the ground for the ground test and co-flight, and we also have a digital space station. The digital space station is used for the pre-mission simulation prediction, co-flight during mission and post-mission status assessment. China's space station is in moderate scale and excellent cost-effectiveness ratio. For instance, it has a high power generation efficiency and a strong experiment support capability. We emphasize the human-oriented design for the safe and effective residence. The station is operated within efficient man-machine coordination mode, such as the console for the robotic arms. The astronaut can control the robotic arm in the cabin, and such as the maintenance tools, body limit, and auxiliary operation devices, anti-draft design. Finally, I'm glad to show the prospect and the future collaboration of the China space station. China always follows the principles as peaceful use, equality, mutual benefit, and common development. And in the new program of application and development, China will continue to adhere the concept of openness and sharing, and conduct more international cooperation and exchanges with the countries and the regions in the whole world. And welcome astronauts from other countries around the world entering China's space station to carry out experiments. The collaboration could be conducted in payload level, technique level, and even in module level. In scientific and technology experiments, many research has been carried out, such as human function and medical research, basic function research on the microgravity, space breeding and planting growth research, new energy research, and space component and parts research. We suppose the cargo airlock in Mengtian experiment module could be food used in the future. As for a payload workshop, satellite in-orbit assembly, EVA equipment maintenance, even for the microgravity and the vacuum lab. I guess Professor Lu Chongming will introduce the advantages of the space lab, more details in the next speech. So, in orbit service field, we focus on the function as a space home port, on-orbit facility constructions, and developing the intelligent space robots. Also, China's space station is very suitable for space education, very suitable and very friendship. We will continue technology upgrading issues In intelligence upgrade fields such as Ethernet, Wi-Fi technology, robotic arm, operation technology, human-machine collaboration based on VR and AR, debris observation, perception, and worm systems, etc. In digital twin technology, continue to improve the precision of the digital model, promote the digital space station to keep approaching to the real space in the orbit, realize the conjunction evolution of the digital space station to the real space in orbit. And we're also developing the big data and AI technology to predict the status and the operation in orbit spacecraft, maybe promoting the development model of this whole space industry. For future exploration, the large payload interfaces are being reserved for future exposed large payload. Additionally, interfaces for later modules are reserved. We will build a 180 tons, 6 module assembly in the future, inflatable and deployable module, not only for the near-Earth spacecraft, but also use a preliminary verification for the future deep space explorations, immigrants, or residents. All of the above points could be considered and achieved maybe by the future collaborations. So at the end, China Space Station will operate in orbit for a long time, more than 15 years, and will continue contributing China's strengths to human beings space exploration and development. That's all. Thank you very much for listening and patience. Thank you.
Thank you very much, Professor Yang and Professor Zhang, for giving such a comprehensive presentation. It showed us a broad and clear picture about China's space station. Now, I will turn it over to Professor Lü Chongmin. His speech is Space Exploration, New Opportunities and Potential, China Space Station Science, Utilization, and Cooperation. Professor Lü Chongmin is Deputy Chief Designer of Space Utilization System of Manned Space Program, Chinese Academy of Science. He is responsible for the overall technical work for space utilization system. He also has engaged in more than 10 space science missions. Welcome.
Good morning, ladies and gentlemen. It's a great honor to be here to share my presentation with all of you. My speech consists of 3 parts. Part 1, Introduction to CSS Research Facilities. As stated as a previous speech, CSS consists of 3 modules. There are 40 experiment racks internal, 51 payload adapters, and 3 payload attach points external. So all facilities can be divided into 5 categories. Now let's give a brief look at these facilities. In space life science area, there are ecology science experiment rack, biotechnology experiment rack, and space radiation biology exposed payload. In fundamental physics, in microgravity, we deployed 2 racks. One is a cold atom experiment rack, and a high precision time frequency rack. In material science, there are continuous material experiment, material furnace experiment rack, and material science exposed payload. In microgravity, fluid physics, and combustion, there are fluid physics experiment rack, two-phase system experiment rack, and combustion experiment rack. Also, we have developed some multiple purpose experiment rack, include a high microgravity level rack, varying gravity experiment rack, science glove box, refrigerator rack, and online maintenance and adjustment operation rack. In order to support these facilities operations and carrying out scientific research and experiments, ground operation and controls networking are established. Its function include mission analysis and simulation assessment, monitoring and control. Especially the payload operation and the application center is the post for scientists to carry out the scientific experiment and do deeply research. Part 2 is CSS research and utilization progress. We also established 5 main objectives of CSS. They are scientific frontier exploration and research, new technology development and demonstration, social, economic, and benefits, science popularization and education, and the international cooperation. Our research and experiment focus on 4 main areas, include 13 research topics and more than 16 research plans. The research area include space life science and human research, microgravity physics, space astronomy and earth science, and space new technology and utilization. Now, here are some experiments that have been done on board the CSS. In the space life science area, the left picture is the research on the molecular mechanism of fluorine regulation in plants under microgravity. We conducted the whole life cycle of rice from seed to seed complete space, and the regenerative rice was successfully obtained. The right picture is the fluorescence imaging of induction process of skeletal muscle cells. In material science, we have conducted the dynamic mechanism of a rapid incarnating growth of alloy was discovered. On the right, we conducted a combustion experiment. You can see the picture we obtained from the CSS. The unsteady and extinguishing behavior of the flame was observed in gravity. Next, the left research is on vibration and flow characteristic of granular materials in varying gravity conditions, include Mars gravity, Moon gravity, and microgravity. The red picture is the results of synchronous extinction of 3 bubbles. The experiment is focused on heat transfer and bubble thermodynamics behavior in pool boiling. In space astronomy area, China Space Station telescope is being developed, which will conduct optical survey and cosmological and celestial research. And it will be launched in near future. So let's take a quick brief of experiment that have been done. More than 113 scientific research projects were initiated, and 65 of which have been implemented. 48 projects are ongoing. The third part is about international cooperation. We have established international cooperation networking, including more than 10 international organizations, such as United Nations Office for Outer Space Affairs, IF, and ESA. So about the cooperation with UNOSA, first round of the CMS and the UNOSA cooperation selected 7 projects from 17 countries to be conducted in the China Space Station. So about the cooperation with ESA, 10 ongoing cooperative projects for the first round, 158 labs from 95 organizations of 23 countries are involved in the cooperation. Finally, we welcome to the international partners to join CSS mission in the way of cooperative research or joint payload development to benefit the science community and the industries, and to promote the peaceful use of outer space. That's all. Thanks so much.
Thank you very much, Professor Liu. We learn more about China's space station research facilities, research project progress, and international cooperation. China will carry out collaboration in experiments on China's space station. One of them is Polar 2 mission. Now we will hear from Professor Nicholas Poudry. He will talk about this mission. Professor Poudry is a research scientist, professor at the University of Geneva. He is mission manager of Polar and the technical manager of Polar 2. Welcome.
Thanks, Mr. Zhou. It's a pleasure for me to speak here. So I will speak to you about a very successful collaboration I had with China. So my goal since several years now is to understand if the prompt gamma ray from gamma ray burst are polarized. This is a very important scientific subject because gamma ray bursts are linked with the birth of black holes, and we don't have a lot of information from those events, and polarization is one of them. How to measure that? Measuring gamma ray polarization is much more difficult than optical gamma ray, where you can just optical light when you can just use a filter. There you have to rely on the Compton process, and you have to have that the photon do 2 interactions in your detector, and then the direction of these 2 interactions is a proxy for the polarization. So the detector can be thought like that. You have a multi-anode PMT and scintillator bars, and you pack many of them, and a lot of electronic, and you can do this experiment. So we built the Polar collaboration. That was a collaboration between Switzerland, China, and Poland. And we submit that to China, and on 15 September 2016, it was sent in space together with the Tiangong 2 space lab. So the launch got a lot of press coverage, and we had fantastic results during this mission, and the results were not at all what people were expecting. So now we see that this is a very difficult subject, and we need a much bigger detector to really understand what is going on. So we start thinking about the next generation of those detectors. And we were able also to measure the crab polarization, which was not a goal of this mission, but I was very good surprised that we can do that. And we even demonstrated pulsar navigation in space. So when UNOSA made a call for proposal to put things on the Chinese space station, we answered this proposal, proposing a much bigger version of Polar, which we call Polar 2. And we were accepted. This is the letter of acceptation, and we built a new collaboration between Switzerland, Germany, Poland, and China. So you see, it's not a very big collaboration. It's something we can do with manageable number of people. This is what it will look. The technology is almost the same than with Polar. We replace multi-anode PMT by silicon PMT. We had to do a lot of R&D because silicon PMT are very difficult in space. They degrade very rapidly with radiation, so we had to do some further study, and this is what it looks. So you see in green was Polar, and if you scale it by 4, because Polar 2 is 4 times bigger, so and the new silicon PM technology enable us to extend the energy coverage to very low energy, and with that now we'll have something which is 10 times more powerful than Polar. We are also studying in some addition to HPD, they are not yet accepted. One is to extend the polarization to low energy with this LPD, and also to do image and measure the energy of photon with another module. So when it will be done in space, we'll be on Wentian modules, and this will look, this is an artist impression of how it will look. And my conclusion is that we are preparing for launch in 2025. When we will be in space, Polar 2 will be the most sensitive GRB detector ever in space. Almost every space agency has sent a GRB detector in space, so there is a big international interest in GRB science. Okay. Thanks a lot.
Thank you very much, Professor Podry, for addressing this Polar 2 collaboration project. We are looking forward to its implementation. Last but not least, allow me to welcome Mr. Wu Lei. He will share his experience on how to boost communication of China manned missions from the media perspective. Mr. Wu Lei is producer and senior space correspondent of China Global Television Network. He has more than 1 million followers on social media, such as Facebook and Twitter. Welcome.
Thank you, Ms. Zhu Linqi, and especially thanks for China Manned Space Agency, as well as China Society of Astronautics, for giving me this chance to share with you some perspective, different perspective from very previous guests and professors. We know that Dr. Yang Hong and Dr. Zhang Qiao and also Professor Liu and Nicholas shared some technical experiments and also the construction of the China Manned Space Station. And I would like to share something different about China Manned Space Agency, China Manned missions from the media perspectives on the global communication theme of these huge projects. And it's my great honor to be here, and my name is Wu Lei, and I'm from China Global Television Network. And, this is, okay. Well, China Manned missions have been developing for several decades, and a lot of global space agencies as well as global space fans have attached great importance to the latest development of China Manned Space missions. And I have shared these latest development on global social media platforms over the past 2 years. And I have over 1 million followers, and I can say that most of the space fans have attached great importance. They want to know more about what is happening on China Manned missions. And whenever I go to the launch site in Zhouquan Satellite Launch Center, I share the latest development of China Manned missions. And they have so many positive feedbacks about the Chinese astronauts or technonauts and what is happening on the scientific experiments on board China Space Station. And I want to share that today I have 4 aspects. The first is the most popular social media posts on manned missions, and secondly is creativity and scientific communications about the manned missions. And third one is how to improve the interaction with the global youngsters, as well as the multimedia communications and media collaborations. And firstly, I want to share some of the examples that I made on my social media platform. And we can see that some of the most popular posts on manned missions about this. This one is Chinese astronaut, technonaut Wang Yaping. She was staying in the China Tiangong space station. And this post is a briefly introduction about their mission on board China's Tiangong station, and over 1.7 million social media feedback on that. And a lot of space fans want to know that their life, their experiments, and also some daily experiment on board the China space station. And also this one is about the Chinese technonaut. This one is about Zhai Zhigang, Chinese technonaut Zhai Zhigang. He's has been staying on board about the Shenzhou 13 crew. And he's been staying in orbit for a long time, over 100 times a new record high for the Chinese astronauts. And a lot of, they have made several spacewalks, and a lot of space fans want to know about their spacewalks and also how to make that exciting experiments on board China Space Station. And also, they have performed some traditional, musical experiments, musical instruments on board the China Space Station, bridging distances between the technonauts. And we can see a very beautiful view here from the China Space Station. And a lot of global space fans, they have left their comments. They really want to know more about the technonauts' life and experiments, and they also have a great expectation about what is happening in the future, because we know previously we have announced that global astronauts and also scientists and engineers are welcome to work and live on board China Space Station. And secondly is about the creative and scientific communications. And I've made a very short and interesting tour to China Space Station last year, and that is Tiangong in orbit, a 7-minute video and shot creative video aboard China Space Station. Of course, we couldn't go to China Space Station right now, but with some creative technologies and shooting skills, we can enjoy and show our global audiences about what is happening on board China Space Station. Starting with the launch of the Tianhe core module in April 2021, China has planned 11 missions to complete the construction of the space station. So at this site, and having floated through space for so long, how is the Tiangong maintaining power? Take a look inside the space station now. On China Space Station, technonauts can now use a mobile app to control the lights. Just like this. There are over 120 kinds of food here, so technonauts will have a different menu every day. Now let's take a closer look at the lab modules. The Wentian lab is mainly for the scientific research of life in space, including the growth and development of different types of plants, animals. Here is a key experimental cabinet called Universal Biological Cultivation Module, where the rice and Arabidopsis are planted. So this is a very short video about the Tiangong in orbit. That is what we have done in 2022. And also we have covered the whole story, not only astronauts, but also the other teams, including the rocket system, and also what is happening in the Dongfeng landing site, those engineers who have welcomed back the astronauts. That's a family reunion photo onboard the China Space Station of the Shenzhou different crew, because we know every year there will be 2 rotations aboard the China Space Station. 6 technonauts in total will be leaving for a while for the rotation. And third one is how to improve the interaction with global youngsters. We know the China Space Station will be in orbit for a long time, more than 10 years. And now Tiangong class is a brand for the space education. We know the Shenzhou 13 crew and also Shenzhou 14 crew, Shenzhou 16 crew, they have conducted 3 space classes with global youngsters, not only American, but also African teenagers, and also with different countries aboard with these space classes. They have shown very interesting experiments in that microgravity environment. We have showed them what is in the experiment, compare with them and talk to the students, and also show them what is, especially to plant the seeds of the space dreams in that youngsters. And we can see this is a Shenzhou 16 crew making experiments and interact with students in China in last month. And also multi-channel communications. Whenever today we are talking about the space research, and we know it's very important for scientists, engineers to conduct jointly, projects, but also it's also critically important to communicate with the world what is happening on board China Space Station. So we have used multi-channels to communicate with our global space agencies, with our global space fans. We have used the live streaming channels, and also we can use interviews. We have talked with different astronauts, talked with experts, talked with youngsters, space agency leaders. We've talked to many, made very interesting talk shows and programs to let us know more stories about the China Space Station. And also, the last part is about media collaboration. We know today we are not collaborating in space agencies, but also in the aspect of media. For example, we have worked with RT and also with Poland TVN24 and also Nigerian TV station on the China Manned Space Station, because the global audiences want to know more about China's space station. And as a media, we have a very good relation with global media outlets. And also, it's very interesting to talk with different media outlets and to let us know what is really the output and aspiration about the China Manned Space Station. And but especially this time at the IAC, and actually yesterday, we, CGTN, had co-produced a special program with Azerbaijan National Television Network, ASTV. We have invited several high-level guests, and we talked about the topic of space for all, creativity and collaboration. And this is a very interesting topic, and we will air that special program tomorrow, and ASTV already aired that on their television network. So that's all. Thank you very much for the media collaboration, and we're looking forward to more collaboration in the future about the China Manned Space Station. Thank you.
Thank you very much, Mr. Wu. China's space station is open to the whole world. We believe that the world will have a better understanding of China's space station through more collaboration and communication. Let us give our warm applause to thank the speakers again. Next, I will invite them to come to the stage to join our panel discussion. Please. So we were kind of running out of time. So here is a question for all of our guests. From your perspective, what insights would you like to share about space cooperation? Professor Yang Hong, would you please share your insight first? Thank you.
Okay, thank you. And China's space station followed the principle of the peace use and equality, material benefits, and common development in the future. And China's space station will continue to adhere the development concept. It's the openness and the sharing, and conducted the more international cooperation with the countries and the regions. Thank you.
Thank you. Professor Liu, would you please share your opinion?
There's no end to space exploration. So is space science and utilization. We expect to jointly propose a scientific research plan and jointly develop some specific payloads in cutting-edge areas. So as to build the long-term, sustainable, and bilateral or multilateral cooperations. Thank you.
Thank you. So, Professor Pojoy, would you like to share with us?
So in science, we expect collaboration, and I have to say that my experience with China was very positive. People have goodwill, and I'm sure it could be improved, for sure, but I'm sure it will improve still.
Thank you. So, Professor Zhang?
Yeah, from my opinion, I talk about from the operations in the technology field. So, as we know, the debris in the field, in the university and the orbit is very awesome, even not very good, and it's terrible. So we can make the collaborations on the debris protect. But first, we should make the assessment, protect, and maybe some defend of it. And the other is we can do more the new for the life support systems. Now we use the biologies, and the biology is a nice choice for it, and we upgrade the technologies. Another is about space robot. Yes, as we know, the space robot from the intelligence field is very quite familiar in the future, and we should do many works on it in the collaborations with others international field. Yeah, thank you.
Okay, thank you. So, Mr. Wu.
Okay, we know that China Space Station is a national space lab, and now besides the International Space Station, China Space Station is a new platform. It's open to global society, and I believe that it is open to the whole world. All astronauts, scientists, engineers can work and live aboard China Space Station. Is a new opportunity. And I hope that one day ordinary people will have the chance to go there, and even including our journalists. I think if we have the chance to go there, that would be great. I would like to go there. Thank you.
Thank you. That was a great discussion. Thank you all for sharing your experience and insights. At the beginning ceremony of IAC, blessings were sent from China Space Station. Technonauts told a touching story about Baku hosting IAC. It also reflects that space exploration requires continuous efforts from generation to generation. It also needs extensive international cooperation. China will continue to build China Space Station into a shared home for all mankind. China Space Station belongs not only to China, but also to the whole world. I would like to close this forum by thanking all of your participation. Thank you all, and good day.